G'day team, welcome back to another video, and today we're going to continue looking at integration and extending that idea a little bit further. Now, before I move on completely, I'm going to go through how to find particular values of integration. And when I'm talking about that, I'm more referring to the constant of integration, that plus c that we have to put on for those definite integrals. Now, if we have a little bit of extra information about our function, like a coordinate, we can actually find that c. So let's run through a bit of an example. So find f of x if f dash of x, my derivative, is 3 cos x plus 3x squared plus x, and I know f of 0 equals 5. So because I've got a derivative and I want to find the original function, I'm going to find the integral of my derivative, which is 3 cos x plus 3x squared plus x, and we have this information, f of 0 equals 5. Now I've got my dx in there as well. Now, because I've only got my derivative, this is useless to us for the moment, so let's calculate my f of x. So 3 cos x, I know cos x goes to sine x when I integrate it, plus 3x raise the power by 1 divide by the new power, plus x raise the power divide by the new power, plus c. So simply all we have to do now is find this c. So f of x equals 5 when x equals 0. So I put 5 on the left hand side and I substitute in 0 for my x. Now 3 over 3 is just 1, so I've got 0 cubed plus 1 on 2, 0 squared plus c. Now this is 0, this is 0, sine of 0 is also 0, so that means 5 equals c. Therefore, f of x without a constant of integration is 3 sine x, I've got my equal sign, plus x cubed plus 1/2 x squared plus 5. And it is as simple as that. So if you're given that extra information for a indefinite integral, you can find that c value by plugging in the coordinate. So I spoke in the last video about extending the idea of integration to functions within functions, a bit like we did with differentiation. So when I've got f of ax plus b, our rules change a little bit. Now, all we have to do essentially is divide by the a value. Every other part of this stays exactly the same, So we can see for e to the ax plus b, the integral was e to the ax plus b, but now we divide by a. Ax plus b to the power of n, raise the power by 1, divide by the new power as such, divide by the a value. Cos of x went to sine of x, now I'm dividing by the a value. Sine of x went to negative cos of x, now I'm dividing by the a value. So it's simple, just makes it a little bit more complicated in terms of our fractions that we end up with, but the rules themselves actually stayed the same. So let's have a look at some examples. Now, looking at this function here, this term here is ready to integrate, this term not so much. So let's first turn this into a function that we can integrate properly. So, like I said, the first term was fine, minus 3. Now, square root, as we all know, is the power of a half. Now, this is in the form that we can look at. So let's now find the integral. So 3e to the 3x plus 2 minus 3 2x plus 1 to the power of a half dx. So the first part, 3 times e to the 3x plus 2, that stays exactly the same to start with. Then I divide by the a value, which in this case is 3 because it's the number in front of x. So divide by 3. Here, we write the same thing again. However, we add 1 to the power. So 1/2 plus 1 is 3 over 2. We're going to divide by that 3 over 2. but we're also going to divide by 2, which is my a value here. So we can see that they'll end up cancelling out, and they will cancel out too. Plus c, because we don't know any other information. So let's tidy it up a bit. E to the 3x plus 2 minus 2x plus 1 to the power of 3 over 2 plus c. Okay, because all of this stuff here cancels out nicely. So there we go. That's it. That's it for that one. Let's have a look now at b. Now, both of these are in the form we can integrate straight away. So let's throw them into our integral. 3 cos of 2x plus pi plus 2 sine of 3x dx. Okay. Now, looking up here, we know cos goes to positive sine. So this is equal to 3 sine. The inside stays the same. However, we divide by the thing in front of x, the number in front of x, which is 2. Now, sine goes to negative cos, so I've got minus 2 cos of 3x, divide by the new power, the thing in front of x, not the new power, plus c on the end. And that's it. That one's done because we can't simplify it any further. So, again, a bit like differentiation when we kept moving through that. It's learning a few new rules and applying them. However, the rules aren't actually any different. We just now divide by the number in front of the x within the function. Hope this helps, and I'll see you guys in the next video.